Today, let us take a look at SCGS Sec 4 Prelim 2021 P1 Question 1. Determine the range of values of m for which the equation 2m squared plus 2m equals to minus x squared minus 2mx plus 3 has real roots. Okay, so from the keyword of real roots, we already have some information to start with, but we don't know whether it's same or different. Okay, so we're going to use the combination of equal and more than sign for part A to do discriminant more than or equal to 0 because we do not know whether the roots are same or different. Okay, so now the next thing is we need to do discriminant b squared minus 4ac. That's how we get that from the equation. That's where some of the students will confuse because this is a good question. They start with 2m squared. Okay, our focus is not only on square but x squared. So I'm going to rearrange everything to the left so that I also arrange them in order. Okay, so that easier for you to get A, B, and C. I'm going to arrange x squared first. Okay, followed by the x value. So the remaining here that does not contain x will all be c value. Okay, so from there, so A we have 1. Okay, remember to take only the coefficient. B we have 2m and c is everything else here. Okay, next we're going to do discriminant, which is b squared minus 4ac, which will be 1 and this. Now look, if you're going to put like this, it's fine, but later you will have too many things over here. So I'm going to take this one away. And I will just retain these two side by side so that it's easier for you to expand, and also it will reduce the mistake of forgetting about this negative later on. Okay, so I'm going to distribute this in as well. I'm going to use back this condition. All right. Squaring this, you have to remember to square both the 2 and the m, so you'll get 4m squared. Distribute negative 4 in, you'll get minus 8m squared minus 8m. Negative 4, negative 3, that's give you positive 12. Okay, next line, combining like terms. This will lead you to a nice quadratic in m. Okay, and we're going to do two things here, negative and the 4. If you are good enough, you can actually do it in one step, but I'm going to show you in 2 steps now, so focusing one by one. I'm going to do the negative first. Okay, we're going to multiply negative, left hand side, right hand side. Okay, so everything here, multiply negative, multiply negative, multiply negative. Now what happens here is that the inequality sign will change. Okay, so this is neutral, that's fine. Okay, so just be careful and take note of this. Okay, that's why I'm doing 2 steps. So next I'm going to divide by 4. Zero divided by 4 is still 0. So notice that I'm doing division everything left and then right. Next step is a quadratic, so let's factorize it. Easy, 3 will be 3 times 1. To get a positive 2, this one needs to be a positive, negative. Okay, check. 3 times negative 1, negative 3. Okay, that's all good. All right, it leads us to a quadratic factorized form with inequality. Okay, so we're going to draw a horizontal line and indicate the root on this position. This one will lead you to a negative 3 root. This one will be 1. So I'm going to place them in correct position. So negative 3 and 1. Okay, next step is crucial. You're going to think of what shape of the quadratic you're going to draw here. Okay, based on the last line that you see, which is here, okay, which is also this one. Okay, so this two we'll see that when you multiply out, the m squared is positive. So from this line, okay, it will give you the shape of the graph needs to be a positive smiley face graph here, this way. Okay, Then next, let's take a look at inequality sign. Less than, which means below. This one means this straight line here, horizontal line, okay? So where is this quadratic below the horizontal line? We should give you this part here, okay? So that is between these two numbers. So we're going to write our conclusion here as -3. Now, be careful of whatever you're writing here. We're solving this one, so which is the n value. Okay, so that's the final answer for part A, right? So next, let's take a look at question B. We need to show that the curve y equals to x squared plus 2k minus 1x plus 1 plus 2k squared is always positive for all real values of k. Okay, so the keyword is always positive. I'm going to draw a tiny thing to let you see how always positive looks like, something like this. So you have two things to prove. First is about the shape of the quadratic. A must be more than 0, okay? And second thing, because it's always positive, means they don't intersect, right? So you have to also prove discriminant less than 0 so that they don't intersect, so that it can be always positive, okay? So now this one is pretty straightforward. You can see it from the equation. What we need to do here is the discriminant first, okay? So I'm just going to write this y again, which is very nicely arranged for you already. You'll see that it's followed by the x term and the constant term, okay? So we're just going to grab the discriminant out from here. Okay, A, B, and C. Okay, go write discriminant. So I'm going to just do it directly, grabbing from this value, b squared minus. Now, same thing, I'm not going to write the 1, so it's 4 times this term, 4 times this, okay? Then be very careful of this expansion. It should have 3 terms, okay? So how you get 3 terms? First, square 2k. Square both of this, you will get 4k squared. Center term, double of what is in the middle. So middle will be -2k. Double it, -4k. And square the -1, then when you get the +1. Okay, expansion of this. There you go. Next step, simplification by collecting the like terms. 4k squared minus 8k squared. Okay, you get discriminant out, but we need to prove less than 0. This is an algebra, right? So what you can do is make use of what you have learned, which is complete the square, and see what pattern you will form by expressing it again. So I'm going to take -4 out of the first 2 terms that contains k squared and k, and put it this way first. Now notice I don't touch 3 because it's not a nice number to factorize by 4. Okay, so I'm just going to factorize this one, so these two are not involved. So when I write the next line, I usually will just put them into big bracket like this one. Okay, and then I will write the center fixed pattern of complete square. Okay, so notice I will put this as negative because it's always fixed. Okay, then I'll do filling of information of these two. Based on this one, coefficient 1 divide by 2, you will get half here. This is positive. So it's positive half. Okay, square this number, 1/4. All right, oh good, complete square, done. Expansion. Okay, -4 multiplied by -1/4, that'll give you a +1 minus 3. Okay, I'm going to write this one up here. So follow through here. Okay, I have the discriminant here. I'm not quite done yet. I haven't proved why is it less than 0, correct? So you're going to have an idea of the square number, okay? So if you square any number, the lowest you can go is 0, and other stuff will give you positive. So you will get this one is always more than or equals to 0 for, if you don't know what to write, just look at the question again. They write it for you, for all real values of k. Okay, we start with this line, the square part, okay? Then let's put these two back in. What happened when you multiply by a -4 for an inequality? Okay, this one, we talked about it earlier. You will change the sign. Okay? Because you're multiplying negative here, but this one it won't affect. Okay? So I've done this. Second one is a -2 here. Okay? So this one, if you have this value, okay, the maximum you can reach is already 0, right? So you're going to minus, you're going to go lower. Okay? So which means the next task, the inequality sign here, will not be 0 anymore, because 0 minus 2 is going to be lower than that. Okay? So notice that this sign has changed. Okay? Because we also want to prove this. Look, this one doesn't have a equal sign, right? So from this to this, you're going to understand why I take away the equal sign. Okay? So from here, we have proved that discriminant is less than 0. Then we make a conclusion that we have proved this too. This one, just take it from the question, the coefficient of x squared. Okay? This one is a positive 1. Okay? I'm just going to write a conclusion there. So coefficient of x squared is positive. Okay? And discriminant is negative. Okay? Therefore, the curve is always positive for all real value of k. Okay, this is what we write in statement, but we have proved it here. Okay, so it's good to just rewrite it again. Thank you.